So Landseer is producing next generation lithium battery anodes with potential to double the energy density of current lithium batteries via a novel production process with unique costs and environmental advantages. So with that, I think we'll start by just having judges who may have a question. Okay, great. Shane, we'll have you kick us off.
Hey, Kurt, good to see you again.
Yeah, you too.
So I got a bunch of dumb questions.
Oh, no such thing.
So I got to be honest with you. Yours, what for me was the easiest to follow. So congratulations on that.
Thank you.
This is a huge market. Obviously, Tesla, right? I mean, just this is like, if we can unlock this thing, this is a huge deal, right? So my question, you had talked about one of the competitors they were trying to, Scylla was using a different processing method, and that's one of their IP that they're trying to go after. You said it was expensive, et cetera. My question to you, if you can talk in very layman's terms, you're taking this corn crap and you're putting silicone and you're baking it, and is that what you're trying to intellectually protect? Or talk to us a little bit more about what is it exactly that you're trying to get in terms of a patent or have it or et cetera?
Yeah, absolutely. So actually your description of it's pretty spot on. Is we call it corn stover, but it's waste biomass. I mean, we pay essentially nothing for it. The process we had the silicon, we don't have the IP fully locked down on that, so I can't say exactly how we're doing it. But basically, we get the silicon in there and we essentially bake it. So it's a bit more high tech than that. There's some pressure steps involved. There are a couple other things, but basically that's the process to make it. And we really like this process because it scales really well. Is that basically we have a little reactor in the lab we make this. I mean, the reactor's, half the size of a water bottle basically. And that we can take that reactor and basically scale it to the point that we're suddenly running tons of it through a huge industrial reactor. As far as the IP on this, we currently have 2 provisional patents. The first of these is how we actually produce the carbon foams, so not pertaining to silicon at this point. And basically, that is that take our corn stove or other waste biomass, and we cook it in a very specialized way. And we're planning to convert that to a full patent actually next month. No one else has demonstrated anything similar to this with biomass. So, the patent attorneys think that we have that part pretty solidly locked down. The second part for the IP protection is basically how we use these carbon foams to stabilize the silicon and make an anode out of it. There are several technical aspects of that, and there's another step in the process we can't really talk about right now for how we make the carbon foam suitable for an anode material. As far as the details of the IP stuff, we've really left it up to the patent attorneys.
Okay. So since we're all racing to have the smallest batteries that are 10 times the life, like obviously my cell phone, I want a battery this big, this thin, and I want it to last 10 times what it currently is lasting. Everybody's racing to that, I assume. So your competitor, not your competitor, the Scylla, yeah. Scylla, they're going down a different path with different matriculation of silicone, et cetera, a different component, a different battery guts, if you will, to compete with your corn or biomass structure of this battery. You have the ability, or it's your hope or your wish to corner that IP so that you guys have that copyright, patent, whatever, to kind of run the gamut, so to speak, for that battery material, correct?
Yeah, absolutely. So to give a little bit of background, Scylla Nanotech is the company has been trying to produce silicon anode batteries. And they've been, to give you an idea of how much interest is in this field, they have, I think, $285 million worth of funding in the past 7 years-ish. And they're advertising a 20% increase in capacity. That said, they have yet to actually produce anything, and they have not said anything about the cost of their batteries. We have actually dug through all of their patents, and they're actually stabilizing the silicon in carbon, so vaguely similar to what we're doing. The process they use to do this, they'll use things like atomic vapor deposition. These are things we can do in the lab, like move individual atoms around, it's great in the lab. When you try to scale this to a commercial process, it becomes insanely expensive. So that's our advantage over them. Hopefully some performance gain, but mainly the fact that we can do this. I mean, basically at the current price are cheaper than the batteries that are on the market now.
Okay. What's your biggest fear with this? Is it a race to lock that stuff down? Is it, hey, does my theorems, protocols, will it work out? What's your biggest fear right now?
Okay, so biggest fear, it's definitely, we have not tested these as much as we would like to. I mean, we have been in the lab, working a ton on this for, months now. It's almost a year now on the anodes. And everything we've seen so far is that they're actually easier to make than we thought they would be. We've put these under all sorts of different analyses. So we have electron microscopes, we have fancy elemental analyzers. Everything we're getting out of these is saying that, yes, we can do this. Every spec we kind of marked out for these anodes, we've hit it until we actually get this into lithium batteries and basically cycle them 1,000 times and show the performance there, which we have a battery tester in the lab, we're actively building batteries, but until we can physically cycle them, we can't say for 100% sure that this is going to meet our targets.
Okay, then on the backside of that, sorry, judges, hopefully this answers some of your questions that you have also. If there was kind of a gold, silver, bronze, as far as monies received, walk me through that. Obviously $1 million or whatever would be your gold, but like you did a really good job in adding up as you went. Where is, obviously you want it all, that's 50,000, that's your gold. So what's silver and what's bronze kind of for you?
Yeah, absolutely. So silver would be, we have it in that document, but $27,000 is what we anticipate getting us to basically our next scale up. We call it lab scale plus in the previous presentation, is basically this is a larger reactor that lets us produce basically anodes with geometries that are going to be really, really helpful. So we can produce better anodes, and it also starts to give us a lot of insights into how we scale this to a commercial process, plus a good bit of money to continue developing these batteries for another 12 months and basically demonstrate the performance of our anodes. I'd say $27,000 would be silver. Bronze, honestly, anything we get. If we get $5,000 out of this, that goes a long way toward a lot of the supplies we need to build these things. Is hopefully we get more than that, but $5,000 would still be great. We can do a lot of good things with that.
And what's more important to you, money or first place?
At the end of the day, we're trying to make this company successful, and we need money to do that. As much as I'd like the pride from winning this, if we can get the funds, whatever that is, that goes a long way toward our ultimate goal. So someone else can have the pride if we can, launch this thing successfully.
And then, jobs in Wyoming. Tell us about your ideal. This would be in Wyoming. Maybe you covered it yesterday, but I just had a list of stuff.
Yeah, absolutely. We touched on it yesterday. I think we'd like to build this pilot plant in Wyoming. We currently have a relationship with some farmers in the region that can supply corn stover. The business environment in Wyoming is phenomenal. The state actually does a matching program for SBIR grants. So if we get, for example, $100,000 for a phase 1 SBIR from, for example, Department of Energy, the state will actually match that, which goes a huge way toward making it easier to scale this up to the pilot plants. Another reason for I really like living here. I would be thrilled to, build this pilot plant here, hopefully employ a dozen people running that. Give me a reason to stay here. That's a great reason. I'd really like to do that.
And then would you anticipate having different locations, or you would keep, once you got huge and you and what's his name from Tesla would hang out together in Wyoming and go fly fishing here, or would you go move someplace else, or what would you do?
Have to talk to Elon Musk about that one, but we haven't planned that far out. as far as what it takes to scale this to full commercial, we really don't have a great idea of what that takes right now. We have like a vague idea on how we get there. We know that. As far as trying to anticipate 8 years down the road, how we're going to build, some facility that costs, $100 million to crank these things out. We don't know what that looks like. I'd love to try and build that in Wyoming. I can't promise that this would be the best state though.
Okay. Talk a little bit more about that. Why not? You have some reservation, like if it got huge, is there talk to us about your reservation there.
Absolutely. Basically, we don't know. Is that we can, on the scale we're doing this now, we can envision what a pilot plant looks like. So a pilot plant would be something that cranks out, say, a ton of material every day. Full commercial, we're saying something that cranks out thousands of tons per day, something on that level. And when you scale it to that, you start to have a lot of things come into play that we don't really understand right now. We're engineers working this in the lab. We're researchers. As far as kind of everything, like how do you build your facility? What are the regulations? How are you importing everything? Do you need rail lines? All of that. We don't understand it. Part of the reason we want to build this pilot plant is it's like, okay, when we have this at reasonable scale, we understand a lot of it better and it helps us move there. So like, I wish I could say we can build, full scale commercial in Wyoming. At this juncture, we can't confidently say that because we just don't know enough.
There's nothing that says that you can't. You're not saying that, oh my gosh, we don't have there's no factor that says you can't. You just don't know if you can.
Yeah, yes, 100%. Maybe I didn't make that clear. We don't know if we can. We'd love to do it. And right now we don't see anything stopping us, but we don't have all of the pieces to that puzzle yet.
Okay, great. Now, Shane, I told everyone they could relax. The questions were going to get easier.
Sorry.
Great job. Great questions. And I think it is great, judges, if you have several succession questions, we have a lot of time. So whereas yesterday we were trying to kind of rush through to get to each judge for a question, we have time to kind of dive in and go a little deeper. So Susan, with that, I'll hand it over to you.
Well, Shane covered a lot of ground, that's for sure. Just a question, Kurt, if this was a race to the finish line and it's time and money, what would that look like to get you to where you need to be to start producing these?
To start producing, okay. So basically if we get enough funds from this, the $27,000 we mentioned earlier, that jumpstarts us a huge way. Basically, we start scaling this up. We can get a lot more data on how well these anodes work. And basically with that, we can go after these SBIR grants and say like, hey, we have all this data, it works. Basically give us the money to scale this up, make these things better. As far as a timeline for that, in this race, if everything goes as planned, we're really hoping to be constructing a pilot plant in just under 3 years. After that, it becomes a little bit foggier, but at the pilot plant level, if we can demonstrate we can produce these things in quantity at the prices we're predicting, at the specified performance, that's very close to, or it's a long way toward the finish.
But if it's not grants, because it takes time to apply for grants and you have to receive the grant. So if it was private funding, can that expedite the timing on it?
Okay, we have not looked into private funding extensively. With the grants is we were hoping to start applying for those, in basically the end of the summer. And with the funding from this competition, that'll basically keep the research and development going until we can start getting hopefully the SBIR grants. Private funding, more money would certainly speed it up. I don't have a good answer for how much.
Okay.
Okay. Other judges, Stephen, do you have a question? Go ahead.
Yeah, thanks, Kurt. Picking up on a couple of the areas that Shane touched upon, and also Susan, I guess one thing is your time. I'm not quite understanding how you spend your days and nights right now, and how do you look at the next year or two, maybe 3 for you? How much time are you devoting to this?
Okay, that's a great question. So right now I'm a Ph.D. student here in mechanical engineering. So I'm actually done with classes as of next week. So currently, in addition to classes, I basically spend my time working in the lab, managing we have a lot of upperclassmen that work in the lab. We have some other grad students, helping them out. Right now, I'm currently working on another project that's funded by NSF. 2 weeks ago, we actually got about $20,000 from NASA that specifically funds me to work on the anode project, essentially full time, from essentially this coming September through next June 2021. So hopefully the next year, starting in September, the following 9 months are devoted almost exclusively to working on this project.
Okay, good. So next question, a little bit of a departure, but it always drove me nuts in presentations. So now I'm getting a little payback. But dive into your backup plans a little bit. You mentioned the risks, so you could go through the risks or all the risks if you want. What keeps you and Erica up at night? But what are the backup plans? What could go wrong, and what could you pivot and do about it?
Okay, that's a great question. So, I mean, on a high level, it's basically right now it's technical risks. It's, I mean, how well can we produce these foams? I mean, the quality of them. There are a lot of technical parameters, everything from the mass loading of the silicon to basically electrical conductivity, and there are things like that. A lot of the stuff we've been doing in the lab the past year has basically been understanding the process by which we make these things. So kind of if one of these parameters falls outside of what we're looking for, we know the knobs that we can turn to technically kind of to fix it essentially. So there's a technical aspect. The thing that keeps me up at night is always having enough funding to keep doing this. The scale up's going to have a lot of risks as well. I think we have that. I mean, a lot of that's in the written proposal. We seem to understand that reasonably well. Right now, we're really just concentrating on the technical aspect. I mean, demonstrating these things can perform as we think they do.
Mm-hmm. Okay, thanks.
Okay, Spencer, go ahead. Oh, sorry, Spencer, you're on mute still. I'm sure it was a really good question, though.
Good. I'm glad I get a restart. I was thinking last night, you're seeing obviously some people looking at the financial viability versus some looking at how it may impact Wyoming. We're looking at both those ideas for these companies as judges. And one thing I was thinking about is, when's your sellout point? So, these companies they're flush with cash. Even if you develop this for say another year and it's still not vetted out, do you wonder if you would start receiving potential offers for them to purchase your IP? And how long are you going to hold out on that and try to keep this in-house, if you will?
Yeah, great question. So as far as basically how long we try to keep this before some potential exit, I really like the idea of, making this my career, or at least a good portion of it is to, start this company and grow it. So kind of looking between the trade-off of trying to grow the company versus just selling out for a bag of cash, I would much rather try and grow this thing. Actually build this pilot plant, supply jobs, provide anode material that's hopefully going to make a bunch of great lithium batteries. As far as what that decision comes down to look like technically, I don't know. But I'm on the side, I'd much rather see this thing grow than just try to sell it out quickly.
And so what happens, say, if one of these companies with all this money comes along and you're at a point where, man, if I just had that money, it would be what we need to fix this. Would you at least, consider standing your ground and saying, well, yes, but I want to build a pilot plant in Laramie or somewhere in Wyoming, and that's part of the terms? Or are those kind of thought processes that be going through your head that come up?
Yeah, absolutely. If I spend all this time trying to set this thing up here, I'd absolutely want to see, these things produced in Laramie, even if I'm not the one in charge of that anymore. And I think if we're trying to, essentially market that, Tesla, Panasonic, whatever, the business climate in Wyoming is phenomenal. It could potentially be much cheaper to produce these things here than, in Texas, for example. Yeah, absolutely. Okay,
and then one more, I'll let Walden go. I was rushed at the end of the last one talking about the sizes. You said you're not obviously planning on doing this on larger like solar type or grid storage type batteries. What cell phones are obviously a big application. Is that the largest you would go, or are there devices larger than cell phones that you would still see a market for this type of battery?
Yeah, absolutely. So as far as the physical size of the battery is a little bit less important as opposed to kind of the performance desired and the price people are willing to pay for that. So as far as building one of these batteries in the lab, you can build, right now we're building coin cells, so something that would like go in your watch or like the alarm for your car. The market we're addressing is hoping to address as far as actually building batteries is basically just very high performance applications. So something that's going to go like in an aircraft or a satellite. And as far as the size of that battery, it's not all that difficult to build a large battery. It takes a little bit longer. We can physically build a large battery. It's just that we're going after something that's a very high value application.
So more of performance over size.
Yes, 100%.
Great, thank you.
Okay, I'll refrain from my snowmobile comments as yesterday, but just know I'm still pulling for that. Okay, Walden, we'll turn it over to you.
It's summertime now, so no more snowmobiling jokes.
That's still on my brain.
Right. So like my big question that came out of yesterday, because I actually thought about this driving home, because like, I mean, in Chicago, we see Teslas every like 5 miles, right? So like they're everywhere. But really like the technology with lithium ions going way faster than they're creating new things for it, right? Because you have all these universities, IBM, big companies coming up with the next batteries that aren't lithium ion, right? So you think what you're developing is already starting to like fall off compared to actually starting to like catch a trend?
Yeah, okay, that's a great question. So is lithium ion basically the future of electrical storage technology?
Yeah, or is like a different mineral compound, or even like, I know like IBM's working on stuff with like seawater that they've already outproduced lithium ion with, right? So like, is lithium ion really the battery that you want to go after, or is your anode something that could be in other batteries also?
Yeah, okay, that is the key point right there, is that a lot of the battery technologies that are kind of, you're seeing in the news, so we've probably heard about solid state batteries a lot recently. That's a type of lithium ion battery, is you take a lithium ion battery and actually replace the electrolyte with something else. So our anodes would be completely compatible with that. So like if you want a solid state battery, whatever performance gains you get from that, you're going to get 50% more performance roughly if you drop one of our anodes in there. There are certainly a ton of other battery chemistries being researched now. As far as things for electric vehicles, cell phones, kind of small, high capacity batteries, there's nothing we're aware of that's remotely close to mass market for that, or that has the potential even at this point. So is there a risk that something comes along and replaces lithium? It's possible. We don't see that happening. I mean, there's nothing out there that would indicate to us that it is happening.
Okay. And then I know one of the biggest issues with lithium is like recyclability and actually discarding it, you know? So what impact does the silicon add or subtract from that equation of being able to disregard lithium?
Okay, so as far as the recyclability?
Yeah. Does it help it or hurt it?
So right now, there's really no mass recycling or hardly any recycling at all of lithium batteries. And there are actually, it's probably a great area to be starting a company in, because there's going to be a huge market for this. But because of that, we don't know what the technology to recycle these in 5 years is going to look like, is unfortunately right now these end up in a landfill. Our anodes really shouldn't make it any more difficult to recycle them, but we don't know what processes are going to be used to recycle them, so we really can't say that for certain.
Cool. And then on the silicone side, like the biomass side, I'll get to that in a second, but silicone, I know like heat and cold won't have too big of an influence, right?
Correct, yes.
But then when it comes to the biomass, wouldn't heat like be kind of like a big issue, and batteries get super hot when they're under a huge draw? So like, wouldn't that hurt the biomass a little bit?
So, okay, so if we were using raw biomass, absolutely. So our lab works extensively with thermal treatment of biomass. I mean, that's one of our main things, is we already heat this biomass to, I can't give you the exact number, but I would say it's over 500 degrees Fahrenheit. So like to process it. So in that processing step, we make this biomass into a form. It's not really biomass anymore. It's almost like a charcoal. Like if you're looking at it, you'd think that's vaguely charcoaly. So these things are actually very, very thermal resistant. Is that people are looking at using carbon foams for things like heat shields on re-entering spacecrafts. Like if NASA's sending a rover to Mars, there has been interest in building the heat shield out of carbon foam. So the carbon foams actually perform very, very well with the thermal cycling and the high temperatures.
Awesome. Thank you. And then, I mean, overall, I hope you do get in contact with Elon, and I hopefully it does come to Wyoming. I guess my question about influencing and affecting Wyoming, I know out there just because of the weather, the tech, like all that stuff, like do you see a big battery boom happening in Wyoming? And if so, what industries would be affected by a battery change out?
Yeah, okay, so...
And we have 2 minutes, so that's your 2-minute warning.
Okay, thank you. As far as what this looks like for Wyoming is we'd really like to, basically build our pilot plant here so we bring in tons and tons of biomass and silicon and actually produce these anodes. Unfortunately, right now what the plan looks like is we're going to ship the anodes out of state to something like Tesla's Gigafactory. If someone else wanted to come in and build a factory in Wyoming to, produce the actual lithium cells, we'd be thrilled to partner with them. Unfortunately, there's no one in Wyoming really does anything significant with batteries that we're aware of now. So
cool.
We can't do it.
Thank you. I'll pass it over to Susan because I know she had one more.
Oh, Susan, you're on mute still.
Sorry.
All good. Nope, totally good.
One last question, Kurt, and that is, it may be in the materials I've forgotten on do you have an advisory group, an advisory committee, or, some sort of experts advising you that you're working with?
We do not right now. That's something we should be looking into at the moment. We do not have any sort of advisory board now.
Okay, thank you.
Okay, that is exactly 25 minutes. So let's give a huge round of applause. Kurt, that was fantastic.